Lesson 11-5, comparing sets of data. A linear transformation is one or more operations performed on a set of data that can be written as a linear function. Common linear transformations are adding a constant to or multiplying a constant by every value in the set of data. So when we look at transformations, we're going to separate them by addition and multiplication, and how does it affect the measures of central tendencies. So for addition, a real number k is added to every value in a set of data where k cannot equal 0. And for multiplication, every value in a set of data is multiplied by a constant, and k is going to be a positive number. How does it affect the measures of central tendencies? So the mean, median, and mode of a new set of data can be found by adding k to the mean, median, and mode of the original set. When it comes to multiplication, the mean, median, and mode of a new set of data can be found by multiplying each original statistic by that k, that constant. And then the spread, talk about the range of standard deviation. For addition, the range of standard deviation of a new set of data will be unchanged, which means it doesn't change from the old data to the new data. But for multiplication, the range of standard deviation of a new set of data can be found by multiplying each original statistic by k. So example 1, find the mean, median, mode, and range and standard deviation of the data set obtained after adding 6 to each value. Now there's two methods you could do. You could add k to the measures of center and spread of the original set of data, or method 2, you can add k to each data value of the original set of data. I'm going to do method 2. So here with method 1, method 2 would be here. So I'm going to just go back to here, actually here, so I can see the original numbers. And I can show you how you can put that in your calculator. So you hit Stat, Edit, clear this. And since this one we're adding 6 to each time, adding 6 to each of them, you can do that as you go. So 8 plus 6, 11 plus 6, 3 plus 6, 15 plus 6, 3 plus 6, 5 plus 6, 7 plus 6, 14 plus 6, 3 plus 6, 5 plus 6, and 4 plus 6. So that puts it all in there for you. Then if we go into here, we can find the mean, median, mode, and range and standard deviation. Now this one is saying to the original data set. So now I'm going to go for the original one. You can see that you have 13, 11.5, 9, 12, and a standard deviation of 4. Now if we use method 2, which we did put them in there, these are the numbers that we entered in. So now if I go back to my calculator here, just to verify that those are the same ones. So you got 14, 17, 9, 21. Let's see, I forgot a 12 in there. So we have 9 values. Let's see. Let me just put these back in here. So 14, 17, 9, at 12, 21, 9, 11, 13, 20, 9, 11, 10. Okay, now we hit Stat, calculate one variable, enter, and then our standard deviation, let's do that first. So that's 4 points. We'll do that 4.0. And then our mean. So we'll scroll down. Actually, our mean is up at the top. So mean is 13. Our median Median is 11.5. Our mode is the number that repeats the most. And it looks like we have a 9 here, a 9 here, a 9 here, so the mode would be 9. And our range, the biggest number is 21, and our smallest number is 9. So 21 minus 9 would give us 12. Now if we compare that to the previous one, we have 13, so the mean never changed, the standard deviation didn't change, the mode. Actually, this is the when you add 6 to those original ones. So if you would find the original ones, you would use these numbers in and enter it. But you should see that your standard deviation would not have changed on that. And the range also would not change because it's still going to be 12 distance away. All the other numbers like your mean, your median, and mode, those would all vary because you'd have to add 6 from the original number to get those numbers. Another example, here we're going to do the mean, median, mode, and range and standard deviation of the data set obtained before and after adding -2 to each number. So we're going to do this twice. So we hit stat button, edit. We're just going to put the original numbers in first. So we got 31, 22, 16, 15, 23, 25, 31, 12, 18, 31, and 28. If I hit stats, calculate, our mean is 22.9. Our median, or our standard deviation would be 6.6. Our mode, the number that appears most often, we got 31 here, a 31 here, a 31. So it looks like the mode is 31. The median, the middle number, let's go back to here, let's scroll down. The median is 23. And the range, 31 minus 12 would give us 19. So the range should be 19. Now if we go back to our calculator, go to stats, edit, where it's now going to add, or really adding a -2 or just subtracting 2 from this. So if we did 31 minus 2, 22 minus 2, 16 minus 2, 15 minus 2, 23 minus 2, 25 minus 2, 31 minus 2, 12 minus 2, 18 minus 2, 31 minus 2, and 28 minus 2. Then hit stat, calculate number 1, enter, and you can see our mean is 20.9. Standard deviation is still 6.6. Median is 21. Our range is still going to be 19, so that's going to stay the same. Because then it would just be 29 minus 10, which still gives us 19. Our mode, the number that appears most often. So if I subtracted 2 from here, that would have been 29. Next, find the mean, median, mode, and range standard deviation of the data set obtained after multiplying each value by 4. So here we go to stat, edit, clear everything. So we have 12 times 4, 18 times 4, 20 times 4, 12 times 4, 18 times 4. Actually, this was 14 times 4. Then 18 times 4, 11 times 4,
21 times 4, 13 times 4, 18 times 4, 11 times 4, and 24 times 4. That calculates number 1, enter. We get our mean as 64. Our standard deviation is 16.8. Our median is 64. Our mode, the number that appears most often, let's see, 18, 18, and 18. So 18 times 4, so 72 is our mode. The range, the 84 minus 44, and that would give us 40. So the range would be 40. So here, if you put it in a table, you put it in a table now. We already found the spread by 4. And if we did the original one, the original for this data set, let me look back at the data set, so 12. The original would have been 16, 16, 18, 13, and 4.2. You can see that they all did change based on what we had here. Just multiplying everything by 4. Moving on to the next one. Find the mean, median, mode, range, and standard deviation of the data set before and after multiplying each value by 1.5. So if we were to put that into our calculators, these numbers, before, the mean before would give us 20, the median would give us 2.2, the mode is 23, the range is 16, and the standard deviation is 5.3. Now, if I were to multiply all those by 1.5, 20 times 1.5 would give us 30. 22 times 1.5 would give us 33. 23 times 1.5 would give us 34.5. 16 times 1.5 would give us 24. And 5.3 times 1.5 would give us 7.95. Next, find the mean, median, mode, range, and standard deviation of the data set obtained after multiplying each value by 0.6. Run to the nearest tenth if necessary. So let's put this into our calculator. We're going to hit stats, edit, clear. Okay, so we have 45 times 0.6 and 33 times 0.6, 43 times 0.6, 53 or 51 times 0.6, 39 times 0.6, 48 times 0.6, 34 times 0.6, 39 times 0.6, 30 times 0.6, 39 times 0.6, 47 times 0.6, and 44, actually 47 times 0.6. Actually, no, that should have been 44 times 0.6. Gives us 26.4. Hit stats. Number 1, enter. Our mean is 24.6. Our standard deviation is 3.7. Our median is 24.6. Our mode, the number that appears most often, It doesn't look like there is one, so there is no mode in this one. The range, our biggest number was 48. So 48 times 0.6 was 28.8. And our smallest number was 30. So 30 times 0.6 gives us 18. So this would give us 10.8 as our range. Next, restaurants. Compare food distributions. The numbers of customers eating in a restaurant during breakfast, lunch, and dinner each day are shown below. So you see the numbers for breakfast, lunch, and dinner. What we want to do is construct a histogram or a box plot for each set of data and then describe the shape in each distribution. Compare the data sets using the means and standard deviation. So I have to do this, you could construct it by entering all the numbers into your calculator, but I have the graphs made for us. So here it says for each time of day, the distribution is, if you look at all three of them, the tallest bar is in the middle. So we would say that the distribution is highest in the middle and lower on the left and right. Therefore, all the distributions are symmetric. If you were doing the box plot method, you would enter all the numbers in, change the stat plot to box and whisker, and then you can compare that from here. You can see that these would all still be symmetric. For each time of day, the lengths of the whiskers are approximately equal, and the median is in the middle of the data, and the left and right sides are approximately mirror images of one another. Therefore, all the distributions are symmetric. Next, if you're comparing the data sets using the means and standard deviation, here you can see means and standard deviation. Means are always the first one, and then the standard deviation is the last one in all the categories. Then we're going to describe the centers and the spreads. So to do that, it says the means vary with breakfast having the lowest average number of customers and lunch having the highest average number of customers. If I go back to that, you can see breakfast has the lowest mean of 59.8, but for lunch has the highest one. Next, however, the standard deviations are approximately equal. If I go back to it, standard deviation 8.3, 8.3, 8.3, or this would be like 8.3, 8.4, 8.4, so roughly equal. This means that while the average number of customers for each time of day is quite different, the number of customers for each time of day generally varies by the same amount from day to day. And next example, television networks use ratings and viewerships to determine which shows to renew and which shows to cancel. The number of viewers in millions for each episode of the first 3 seasons of a popular sitcom is shown below. So I have that all on a histogram here. That's for each season. The distribution is tall in the middle and short or low on the left and right. Therefore, all the distributions are symmetric. Next, the weights in pounds for a sample of retrievers, German Shepherds, and Golden Retrievers. What we want to do is use a graphic calculator for each set of data and describe the shape of each distribution. So to do that, go grab our calculator here. Hit the Stat button, Edit, Clear, and we're going to type in for the Labrador Retriever. We got 75, 59, 63, 68, 67, 59, 69, 63, 60, 76, 70, 74, 67, 68, 71, 65, 62, 74, 66, 78. Then if I hit graph, let me check my stat plots. Okay, let me choose this one. Then hit graph. Need to change my Windows settings. So see, let's do 10 maximum. It would be, just make this 90. Count by tens. Then graph that. We could do the other ones. Let's do the other ones as well. So let me go to Stat, Edit, put the other one, 53, 61, 58, 74, 85, 80, 72, 57, 64, 69, 81, 75, 73, 64, 76, 68, 66, 51, 67, 73. And on the other side, let's do 62, 59, 67, 72, 64, 67, 69, 76, 63, 64, 73, 69, 71, 75, 59, 64, 69, 59, 74, 68. Now if I have to turn my other plots on, so a second here, I'm going to turn this one on. And change this to I need to change this one to L2. So I hit second, put L2 in there, and then go to second, y equals, turn the third plot on, hit enter, turn it on, hit enter, go down, hit enter, change this one to L3, so second, 3. Now if I hit graph, I can see all three on here. I can compare them. So we're going to compare the data sets using the means and standard deviation. What conclusions shown on the next slide can you make about the sets of data? Select all that apply. I put that. Okay, so the average weight of each breed is about the same. So the average, we could say that that is true. B, the weights of all three breeds are very close to their means. Look at that. They're not real close because they are skewed a little bit. We can't say B. C, the weights of the German Shepherds vary more than other breeds. So the German Shepherds were first. And you can see that there's a bigger gap, like the whiskers are a little bit longer or different shapes, so that we could say C would work for that one. D, on average, the golden retrievers weigh much more than the other breeds. Actually, the German Shepherds was the second graph. So the second one right here. Then the middle one, so then the golden retrievers are the third box and whisker plots. So on average, golden retrievers weigh much more than the other breeds. We cannot say that. E, the means of the weights differ by less than 1.5 pounds. That one we can say is true because they are very close to each other, which is less than 1.5 pounds away. And then F, the weights of the Labrador retrievers and golden retrievers are generally closer to their means than the German Shepherds' weights are to their mean. So the retrievers are your first and third. So if I go back to first and third look very similar to each other compared to the middle one. So we could say letter F as well. Moving on to example 4, the number of high school boys and girls of hundreds of thousands participating in tennis in several recent years are shown below. So here you have boys and girls in hundreds of thousands. We're going to construct a histogram or box plot for each set and describe the shape of each distribution and then compare it. So again, you follow the same steps as we've done before. I already have that completed for us here, so we're going to use the graphs here. Both distributions are high on the right and have tails on the left. Therefore, both distributions are skewed, and these we would say are skewed negatively. As you're doing the box plots, there you can see your box plots, and we can also describe those with the 5-number series. Both distributions are skewed. So you'd use the 5-number summary to compare, and here's your 5-number summary. So the upper quartile for the number of boys that participated in tennis is, so if we go with boys, the upper quartile, which would be quartile 3, and quartile 3 would be 160, while the minimum number of girls that participated was 160. If you look back here, the minimum was 160 for the girls, the maximum for the boys was 160. This means that there were only 160,000, remember this number is in the thousands, or more boys participating in tennis for 25%. And it's 25% because if you were look at the box and whisker plots, this is 25, this is 50, this is 25%. Years while at least 160,000 girls participated every year. We can conclude that many more girls participated in tennis during this time than boys. In our next example, mathematics SAT scores for students in 2 of Mr. Ahmed's class are shown below. Again, we're going to construct a box plot for each set of data, and then describe the shape of each distribution, and then compare the data sets using the 5-number summaries. So let's go back to our numbers, and we will enter these into our calculator. So again, we hit Stats, Edit. We're going to clear what we have in here. First one, we'll do the second period. So we got 562, 604, 580, 625, 578, 591, 610, 525, 600, 572, 592, 531, 598, 611, 554, 606, and then fifth period, we have 571, 539, 602, 547, 583, 600, 542, 581, 559, 526, 562, 585, 611, 564, 582, 582, and 566. Once I have them in here, I'm going to go to second plots, just make sure those are all on. Need to change this one to L2. Second L2. Then if we hit graph, let me get out of that. I'm going to turn this one off. Change our Windows settings. Got to change those. So let's change this to 200 and this one to 800. We'll count by 100s. Then hit graph. Let's extend this, change this, instead of counting by 100s, let's count by 50s. Count by, hey, let's try 10s. We'll change this to 500. Okay, that one looks like a lot better. So what we're going to do with that is we did do a box plot for each and describe the shape. So let's describe the shape here. So we can see the top one. So this would be the second hour. It's shifted towards the right. That means the longer stem or the longer whisker is on the left. So this is skewed left. So second hour would be negatively skewed. Fifth hour this one, it almost looks like that one would be pretty much symmetric. So we would say fifth hour is symmetric. Part B says compare the data sets using the 5-number summary. We're going to do that here on this slide here. So it says for second period, the left whisker is longer than the right, and the median is closer to the right whisker. The distribution for this one, as we said, was negatively skewed. For the fifth period, the length of the whiskers are approximately equal, and the median is in the center or middle of the data. The distribution is symmetric. Now the comparison, the upper quartile of fifth periods scores is 584, while the median of second period's scores is 591.5. And if you're wondering how we came with that, if we go back to our graph, our table, go to stats, calculate, choose option 1, hit enter. In the 5-number summary, there's our median of 591. This means that 50% of second period scores were higher than 75% of fifth period scores. And overall, fifth period scores are lower than second period's scores. Now, what you could do through the comparison is just take the 5-number summaries and write them down for each one, and then just compare it that way. Otherwise, we can use statements such as these to answer that. Next example, it says the number of raffle tickets sold by Darius and Micaiah each day are shown below. So Darius, you have their numbers. Micaiah, we have her numbers. What we're going to do is use a histogram or a box plot for each of the data, describe the shape, and then compare the data sets using the 5-number summaries and write down some conclusions shown on the next slide about those. The first step is to enter them into our calculator. So we'll grab our calculator here, hit stat, edit. We're going to clear what we have in here. Okay, so Darius will be the first one. So you got 5, 1, 15, 4, 10, 23, 9, 3, 17, 2, 6, 21, 5, 13, 28, 10, 14, 7, 5, 19, 9, 22, 10, 8, 15, 9, 13, 19, 22, 30. And then going over to Micaiah's, we got 18, 1, 17, 10, 19, 3, 7, 20, 9, 22, 12, 13, 16, 18, 16, 5, 17, 15, 6, 11, 18, 14, 16, 18, 1, 16, 18, 23, 15, and 10. From that point, we're going to create our box and whisker plots. Just want to make sure that these are on. They are. If I hit graph, I have to change the window settings. So let's change it from 0. The maximum, let's just go by, I think we could go, let's go 40. Count those by 5. And graph it. There we have our 2 box and whisker plots. We can say the first one, so Darius, his is the wonder whisker is on the right, so that means that is positively skewed. And then we got Micaiah, hers is the other direction, so Micaiah would be negatively skewed. So we have like the mean, the minimum, the quartile 1, the median, and the maximum for Darius as 12.5, the minimum 1, quartile 1, 6, the median 10, the max is 30. So to do Micaiah's, We're going to do the median, the mean, the minimum, quartile 1, median, and the max. The first thing I'm going to do is plug those back in here. So we got 18, 1, 17, 10, 19, 3, 7, 20, 2, 12, 13, 16, 18, 16, 5, 17, 15. The rest we got 6, 11, 18, 14, 16, 18, 1, 16, 18, 23, 15, and 10. Then hit stats, go to calculate, number 1, enter. Our mean is 13.6. And our 5 numbers summary minimum is 1, quartile 1 is 10, the median is 16, and the max 23, and quartile 3 is 18. Now let's look at here. It says the median number of tickets Darius sold is much higher than the median number of tickets Micaiah sold. We compare the median. The medians are 16 and 10, so Micaiah is more. So we know that this one is not true. The median number of tickets Darius sold is the same as the lower quartile Micaiah's sale. So the median Darius the median was 10. The quartile 1 was 10, so they were the same. So letter B would be true. Next, the data from Darius' sales is spread over a wider range than the data from Micaiah's sale. That one would be true. There you would use the spread. They both had the low of 1 and a high of 30. Letter D, the median number of tickets each student sold was the same. That is not true. The fewest number of tickets each student sold in a day was 1. Letter E, that was true. And letter F, the upper 50% of Darius' data stands from 10 to 30, while the upper 75% of Micaiah's data stands from 10 to 23. That is also true. So that is our lesson on comparing sets of data.